Hi, welcome back. In this video, we're going to talk about rational exponents. In other words, we're going to be talking about how to simplify radicals and how to deal with square roots. Let's begin. Now, to sort of introduce this concept, I want to review a little bit of what we've already covered. As an example, we've covered several things. We've covered what happens when we deal with positive exponents, right? We have 4 times 4, which is 16. We've spoken about 0 as an exponent and how that always equals 1. We've dealt with negative exponents and how that flips over as a fraction, right? 1 over 4 squared to make it, we do the reciprocal to make it positive, which is also 1 over 16. And then, we've spoken about a lot of things, right? 4 to the 1 power is 4, just to fill in some blanks. Okay, so we've spoken about different integers, zeros, positives, negatives. What do we do with exponents? Now what we're going to talk about is we're going to be dealing with a rational exponent. Now, a rational number is really any number that can be expressed as a fraction. So what do we mean? Now we're really talking about what happens when we have 4 raised to the 1/2. Half is going to be a number between 0 and 1 as an exponent. So then the value of 4 to the 1/2 will be something between 1 and 4. And that's what we're trying to talk about today. What is that value going to equal? Now, it doesn't have to just be 1/2. It could be anything. Anything in between these integers. Like, let's say if we have 4 to the 3/2. 3/2 is another way of saying 1.5. That's between the exponents of 1 and 2. So then the answer, or the value of 4 to the 3/2 should be somewhere in between. Okay? So, we are dealing with an exponent that is not a whole number. And what do we do when it's not a whole number or an integer? That's what we're talking about today. Now, throughout this video, I'm going to be making a lot of examples to show you how to navigate this rational exponent process. Feel free to watch as much as you need to or pause at any time. Once you feel like you're getting a really good hang of it, you do not have to watch the rest. Just don't forget to like and subscribe. All right, let's talk about what the definition is, the technical definition of a rational exponent. So a rational exponent can be expressed like this. It's really any number, any value raised to a fraction as an exponent. Now, the technical definition is we take this lower value, this n, and that becomes the square root or the nth root of what's left over, x to the n power. This is what I mean. This represents the nth root of x to the m. Notice how I keep the n goes down here in the front and x to the m goes on the inside. So we're really dealing with some sort of square root, some sort of radical. Now this n represents the root that you're taking. You can have the square root if it's a 2. You can have a cube root if it's a 3, right? And what a square root is, or a radical, is if we think back to middle school, is we can say that a square root is when you're multiplying a number times itself, right? What number multiplied by itself gives you this value? And we'll do some examples here in a little bit. But here's one that we're going to be looking at quite a bit. What we're going to focus most on this video is what happens when we raise something to the 1/2 power. Let's say 16 to the 1/2 power. If I follow my rule, the 2 will go on the outside, and then the 1 will stay with the 16. Right? So this 2 will go here, and then the 1 will stay with 16. And 16 to the 1 power is just 16. Right? 16 to the 1 power is simply just 16. So what this says is, what is the square root of 16? What number times itself, if you multiply that number times itself twice, what gives you 16? And the answer here is 4, right? 4 times 4 is 16. If we're dealing with the cube root as another example, let's say that we have, let me move this a little bit, make some space. Here, let's say that we have 8 to the 1/3. This is known as the cube root of 8. Now we're thinking about what number times itself, if you multiply it 3 times itself, will give you 8. And that's going to give you 2 times 2 times 2. Right? So this number in the front of the radical is really the nth root. It tells you how many times you need to find a number multiplied by itself to give you this term. Here we had a 2, so we're only looking for a number multiplied by itself twice, and that's why we had 4 times 4, right? 4 is the square root of 16, and 2 is the cube root of 8. Now, our main focus, as I said before, is dealing with to the 1/2 powers, just square roots. We can talk about this later in math. For now, let's focus on simplifying radicals when it's the square root of a term. Now, this 2 here is not necessary. The square root already is implied that you're only looking for a term multiplied by itself. So let's talk about how to do this. Let's talk about perfect squares first, right? If we're trying to undo this process, let's talk about the process that we have been doing. We have been focusing on examples like 1 squared, which is 1 times 1. 2 squared, 2 times 2, that gives us 4. 3 squared, I can really square any term I like. 4 squared. 5 squared. Oops, 5 times 5. Right? All of these terms are being squared. So what we're doing is when we're trying to find the square root, for example, the square root of 25, we're trying to really work backwards. What number did I multiply by itself to give you that 25? And that gives us 5, right? So this really is equal to 5. We found a number, we found this pair, 5 times 5, that gives us 25. If we wanted to find the square root of 16, we're looking backwards again. What number did I multiply by itself to give me this square root, right? So if you're dealing with a perfect square, you can always find it on the calculator. If you don't know your times tables, you can always go to your calculator. There is a button here on the left, the control button. And then you find the x squared button. And because squaring a number and square rooting a number are inverses, they're always going to be right above each other. So what you do is you press the control button first. It's usually the gray or the orange button. You press the control button, then you press the x squared button, and the square root pops up. And you can just type in any number. Can we find the square root of any number? And if it's a perfect square, you're going to get a whole number. You're going to get 1, 2, 3, 4, 5, and this list continues, right, to infinity. If you get a decimal, then you're not dealing with a perfect square anymore. You're not dealing with a whole number multiplied by itself. You're dealing with something in between. For example, what if we had a scenario that looked like this? What if we wanted to find the square root of 8? 8 is somewhere in here. So I know that the square root of 8 will be something, a number between 2 and 3. Right? Between 2 and 3. 2 times 2 is 4, and 3 times 3 is 9. So to get 8, we're going to have to multiply a number between 2 and 3, some sort of decimal. Now, these decimals, we're trying to avoid the decimal part. So what we're talking about in this video is how do we simplify a radical so that we can avoid the decimal. And that's really what we're doing here. We're simplifying square roots or radicals. We're simplifying them mainly for numbers that are like these, that are between perfect squares. Because the perfect squares can be simplified in the calculator. We can do the rest. We can do everything in between. Like the square root of 20 would be somewhere between 4 and 5. Right? All right. Let's just walk through this examples. Let's walk through a few examples. How do we simplify a radical, and how do we deal with it? Let's get right to it. So, here on the left, you have a list of perfect squares, so you can get a reference of where you're looking for or what you're looking for. But this list can continue, right? I have it up to 9 squared. 9 times 9. We can go 10 squared, 10 times 10 to get 100, 11 squared, right? The list continues. It doesn't have to stop. I just put this on the left as reference. So let's talk about an example. Let's say that we're looking for the square root of 20. Let's start with 20. The square root of 20, okay? Now 20 is here, which means it's going to be a number between 4 and 5. If we put square root of 20 in the calculator, we're going to get 4 point something, right? I'm going to avoid the decimals, and this is what we're doing. What we do to simplify a radical is we're going to take the number inside the square root, and we're going to break this down as much as possible to factors or things that multiply to give you 20. And here's what we do. So 20 can be expressed, since it's an even number, it can be expressed as 2 times 10. Right? Now the 10 can be broken down even further. Right? The 10 could be expressed as 2 times 5. So I'm going to continue to break the numbers down. I bring down the 2 that I already had, and the 10, I write it as 2 times 5. And then I'm left with 2 times 2 times 5. Now the 5 can't be broken down any further. It's just 1 times 5. And what I'm looking for here is I'm looking for this pair. Notice how I have a pair here, right? These pairs are going to be part of my perfect squares. So whenever I find a pair of numbers, I'm going to take that pair and I'm going to bring one of those numbers out of the square root. I'm going to put it in front of the square root. And the numbers that do not have pairs, like the 5, will stay inside the square root. So square root of 20 is the same thing as saying 2 radical 5. You can put both of those in the calculator. You can put radical 20 in the calculator. You can put 2 radical 5 in the calculator, and you'll get the exact same decimal value. Again, we're trying to avoid decimals because radicals are going to be more accurate. And here we have our first radical. Let's try another one. I'll do this one in a different color just in case things get confusing. Let's say that we're dealing with 28, the square root of 28. Now 28 is an even number. If you know your timetables, you can think of 4 times 7. But if you don't, you can just say, hey, it's an even number, I'm going to divide by 2. So I can rewrite 28 as the square root of 2 times 14. 14 also happens to be an even number. So I'm going to divide it by 2 again. I copy down the first 2, and then I just change the 14 as 2 times 7. Since we're finding factors, everything here is being multiplied. Everything. Even before, in the previous example, 2 radical 5 means 2 times radical 5. Okay? Now, the 7 can't be broken down any further. This is how I know when to stop. When you cannot rearrange a number into another set of factors. So 7 is just 1 times 7. I notice that I have a pair of 2's. One of these 2's will come out in front of the square root, and the 7, because it does not have a pair, stays inside the square root. That's 2 radical 7. Right? This simplifying radicals comes down to practice. So I'm going to do a lot of examples in this video. Feel free to stop when you have the hang of it. Or feel free to pause the video, give them a try. Because until you try it yourself and you start finding these patterns or until you start finding these pairs of numbers, you're not going to really know how to do it. Let's do one more, and then I'm going to stick to doing 2 per slide. Let's do another one here. Let's say that we have 24. I'll go back to blue. Or you know what? We'll do it black. The square root of 24. Now I can break this down as 4 times 6 or 2 times 12. Whichever route you take will give you the same value. Let's do this with 4 times 6. The 4 can be broken down as 2 times 2. And the 6 can be broken down to as 2 times 3. Notice how the 2's cannot be broken down any further and the 3's can't either into more factors. And this is how I know when to stop. If I went the other route Let's say that I went as 2 times 12. The 12 can be broken down to even more numbers. I can break down the 12 as 2 times 6. And then the 6 can be broken down even further as 2 times 3. So I have 2 times 2, and the 6 is 2 times 3. Notice how these are identical. I have 3 2's and 1 3, 3 2's and 1 3. They're both, whichever route you take, will give you the same value in the end. I'm still going to end up having one pair of 2's, and that's going to come out in front of the square root. And because the 2 and the 3 do not have any pairs, I'm just going to multiply them. So 2 times 3 is 6. And I leave this as radical 6, 2 radical 6. I could have done the same thing with blue, right? I have a pair of 2's. That one comes out. And then the 2 times 3 on the inside stays at 6. 2 radical 6 is your simplified version. All right, let's do some examples. Let's talk about the square root of 27. (27) is not an even number, so it cannot be divisible by 2, but it can be divisible by 3. I can break this down as 3 times 9. I can break down the 9 even further as 3 times 3. Now that I can break down any number further, I look for pairs. Notice how there's one pair of 3's that I can pull out as a 3, and the other 3 that was left over, since it does not have a pair, it stays inside. 3 radical 3. You ready to try some on your own? Feel free to pause this at any time, give it a try, and see how far you can get. All right, let's talk about, let's say, 45. The square root of 45. Again, I'm strictly choosing numbers that are between these perfect squares, between 36 and 49. So these are not going to be nice numbers. If I get a number that is a perfect square, put it in the calculator, you'll still find out what it is. We can even use this method for perfect squares if you don't know this list by memory, or if you don't have your calculator handy. So 45 is divisible by 5 because it ends in 5. So you can divide this by 5. And you can say I have 5 times 9. 5 times 9 is 45. The 9 can be broken down even further as 3 times 3. So I copy the 5 and I just copy down the 9 as 3 times 3. 5, 3, and 3 cannot be broken down any further. And here I found a pair of 3's. That's what I'm looking for. I'm looking for the pairs. The 3 will come out to the front of the square root, and the 5 will stay inside because it does not have a pair. That's 3 radical 5. All right, let's try some more. Let's say that we're dealing with the square root of 32. (32) is an even number, so I can divide it by 2. That is 2 times 16. Feel free to use your calculator for this part if you're trying to divide things by 2. Now 16 can be broken down into even further. 4 times 4 or 2 times 2. Sorry, 2 times 8. So I'm going to write this as 16, I'll write it as 4 times 4. Notice how I have a pair of 4's here. I can stop already. I know I can break down the 4 as 2 times 2 and 2 times 2, but whenever I find a pair, I want to stop there, pulled out into the front. I have 4 comes out, and the 2 that does not have a pair stays inside. Now let's say that here I wanted to do a different route. Let's say that here, instead of saying 4 times 4, I wanted to express that as 2 times 8. Right? Maybe you weren't thinking 4 times 4. You can always break down the 8 even further. have 2 times 2, and then the 8 can be broken down as 2 times 4. Right? The 4 can be broken down even further as 2 times 2. You just have to keep track of how many 2's you have. I have 2 times 2 times 2, and the 4 has 2 times 2. Then I start pulling all of the pairs out. I have a pair here and a pair here. So 1 2 comes out, and then another 2 will come out, and there's 1 2 left by itself on the inside. Since we're dealing with factors, everything's being multiplied. So whatever you pull out, whatever comes outside of the square root will also be multiplied. So on the outside we have 2 times 2, and on the inside we just have radical 2. Same solution. They're both going to get you there. If you break it down as much as possible and you're trying to find pairs of numbers, you will always yield with the same result. That's what this is all about, simplifying the radical. Okay, let's do a few more. Let's say that we have the square root of 72. Now, 72 is an even number, so you can break this down as 2 times 36, or you can break this down also as 9 times 8. Both numbers, 7 and 2, add up to 9. So anything that adds up to 9 will be divisible by 9 as well. Let's go about 2 times 36. Again, it does not matter how you write this, right? As long as you keep breaking down and finding the pairs, you'll find the same solution as I did. So 2 times 36 is 72. 36 can be expressed as 6 times 6. I found a pair of 6's. I don't have to break down the 6 even further. That pair will come out, and the 2 will stay inside. Now, if you break it down as 2 times 3 and 2 times 3, you'll have more numbers come out, right? And then as you start multiplying them, you end up getting 6 radical 2 as well. You'll get the exact same thing. All right, let's try another example. Let's say that we're dealing with the square root of 54. (54) is an even number, so you can break it down as 2 times 27 or 9 times 6. Let's stick with 2 times 27. The 27 can be broken down even further as 3 times 9. So I bring down the 2, and the 27 turns into 3 times 9. The 9 can be broken down even further. I have 2 times 3, and the 9 is the same as 3 times 3. Since I can't break anything further, I start looking for my pairs. I have 1 pair of 3's right here. That number will come out, and on the inside, I have 2 times 3, which is 6. So square root of 54 is the same thing as saying 3 radical 6. All right, here for the last ones. What if we have something like the square root of 38? It's an even number, so I can rewrite it as 2 times 19. Now the 19 cannot come out any further. Did I find any pairs? No. This is a number that does not have anything simpler. It's already in its simplest form. That just simplifies to square root of 38. That is the smallest that I can take it. Since there were no pairs involved, I leave it as is. And that happens with fractions, right? Sometimes you can simplify a fraction, sometimes you can't, because there's no like terms, or there's no common denominators. Let's try another one. Let's say that we have the square root of 30. Here's another example. (30) can be expressed as 2 times 15. And the 15 can be expressed as 3 times 5. So I have 2 times 3 times 5. Did we find any pattern? Any pairs? No, no pairs. So this can stay as the square root of 30. Sometimes you will find pairs and those numbers will come out. Sometimes you don't. It's just what it is. Please let me know if you have any questions in the comment section. I can help you do any square roots that you have in common. But simplifying radicals, we stuck to just square roots for today. Square roots, or something to the 1/2. Maybe later I can do a video on to the 3rd power or 2/3 or more complex situations. Hope this has helped. If you have not subscribed so already, please do so right now. Click the like button, and as always, we'll calculate later.